Okay, so in our previous lesson, we learned about the fact that when we were graphing, there's times where sometimes you might be graphing and you'll have a parabola and a line intersecting it, in which case you'd have two solutions because there'd be two intersecting points. Well, that's how we'd be able to tell if we're graphing just by looking at the graph that there's two intersection points. So what does that look like when we're using the substitution method? Well, in the second part of this video, the second part of this lesson, we're going to be looking at some unique situations. So one of those unique situations is when we have more than one solution. So let's look at this first example. Here we have y equals 4x. I'm going to substitute my value for 4x in for y in the other equation. Now here's a little note about substituting. Anytime you substitute a value in for another one, and there's going to be multiplication involved, make sure that you put the substituted part inside parentheses. It'll help you avoid some mistakes, which will especially be true in the next example we look at. Okay, so now I have x times 4x. Well, x times 4x would be 4x squared. Divide both sides by 4, and I get x squared equals 9. Now, we want to figure out what squared would give me 9. Well, you might think, well, 3, because 3 squared is 9, which is true, but there's another answer. Now, if you take the square root of 9 on your calculator, it'll only give you 3 as your answer. But we need to remember that we're not just taking the square root of 9, we're putting numbers in here for x. So there's one other value that I could square that would give me 9 as my answer, and that's if I squared negative 3. So I'm going to have two solutions for this one, 3 and negative 3 for x. I just have to figure out what y is. Now to find y, I can use 3 in either equation, so the first one makes the most sense. Well, 4 times 3 is 12, so it means y equals 12, or y equals 4 times negative 3 is negative 12. Oops. So what we have here is when I put 3 in my equation, I get 12 as my answer. When I put negative 3 in my equation, I'll get negative 12 as my answer. So this would be a situation involving two solutions. So why don't you do the same thing for the next one? So take a minute, figure out how many solutions this one has, and find each of them. So why don't you pause the video and hit play when you're ready to check your answers. Okay, so you should have substituted 3x in here for y. So it's going to be x times 3x equals 48. Well, x times 3x would be 3x squared equals 48. Now if I divide both sides by 3, I get x squared equals 16. Now that doesn't mean that 4 is my only solution. It means I have 4 and negative 4. So don't forget, all we found is the x values. I need to figure out what y is for each of these. So now I put 4 in for x. So let's put it in the first one. So it'll be y equals, 3 times 4. And y equals 3 times negative 4. So again, I'm going to get 12 and negative 12 for my values for y. So when x is 12, or when x is 4, y equals 12. When x is negative 4, y equals negative 12. So there's my two solutions. Now if I have two solutions, if I have one solution, if I have 15 solutions, if I ever have one or more solutions, we say that in that case the system is what we call a consistent system. The only time that it's not going to be a consistent system, the only time that we wouldn't classify it as being consistent, is if the system has no solutions. Then we say it's inconsistent. So again, that means that anytime we have no solutions, it's the only time that we would refer to it as being an inconsistent system. Now, as far as graphing is concerned, let's say if I had a parabola and I had a line like this that did not intersect it. This would be a situation that would be inconsistent because we would have no solutions. There's no spot where these intersect at. Or if you had two parallel lines, those two lines would also be inconsistent because they're not going to intersect, so there's no solution there. Now, what does that look? That's easy to see when we're graphing it, but how can we tell that when we're looking at using substitution? Well, let's look at this first one. We have x equals 4 minus 3y. And then the other equation, 2 times whatever x is, plus 6y equals negative 2. So I know x is the same as 4 minus 3y, so I'm going to put that value in here for x. So it's going to be 2 times that value, so again, put this in parentheses. So it's 2 times this whole thing, 4 minus 3y. And then plus the 6y equals negative 2. Distribute the 2 through, so I get 8 minus 6y plus 6y, whoops, equals negative 2. And now if you notice, negative 6y plus 6y, they cancel each other out. That does not mean that y equals 0. That means the y's are completely gone. I'm left with then 8 equals negative 2. Well, hold on a second. 8 doesn't equal negative 2. That's not true. That doesn't mean that we made a mistake. What that means is that if you ever have a situation like this where your variables cancel out and you're left with a false statement like this, what that means is that we have no solution here. If we were to classify this system, we would say this one is inconsistent. Now, if we were to graph these, because look at these, both of these are linear. This is x equals 4 minus 3y. That would be a linear equation. 2x plus 6y equals negative 2. That's a linear equation. So these would be two like the ones I have up here. If we were to graph these, they would be parallel to each other. Well, let's skip down here, and let's look at this example. So again, here's one where I'm going to substitute negative 3x plus 2. I want to put that in here for y. So it's going to be 15x plus 5. In parentheses, I'm going to put negative 3x plus 2. Because again, that's what I'm substituting in there for y. So it's going to be 5 times the whole thing. And then all of that is going to equal 10. Distribute the 5, and I get negative 15x plus 10 equals 10. Notice 15x minus 15x, those cancel each other out. That does not mean x is 0. That means that it's gone completely. So that means all I'm left with on the left side of the equal sign is 10. On the right side I have 10. This time I have a true statement. So compare and contrast here. In the previous example, the variables cancel each other out. But in the previous example, we were left with the false statement. In this one, we're left with the true statement. So we're not going to have no solution here. What this means is we have infinite solutions. Meaning in this case, if we were to classify it, it would be consistent, because the only time it's inconsistent is if there's no solution. Any other time, if I have 1 solution, 2 solutions, 10 solutions, infinite solutions, I would classify it as being consistent. Okay, so this one here, 4b, we're not going to worry about, but I do, because it gets kind of ugly there, but I do want you guys to try 3b on your own. I want you to see if that one's going to end up being no solution where it's inconsistent, or infinite solutions where it would be consistent. So I want you to take a minute, pause the video, and hit play when you're ready to check your answer. Okay, let's check to see what you did. Here we should have taken 3 minus 2y. We put that in for x, so it's going to be 3 times the quantity 3 minus 2y plus 6y equals 6. Distribute that through, we get 9 minus 6y plus 6y equals 6. Well, you can see here the y's are gone because negative 6y plus 6y would be nothing. 9 does not equal 6, so this would be no solution. And if you were asked to classify it, we would say this one is inconsistent. Okay, so hopefully you have a better idea now of how to use substitution. It's a pretty easy concept. The one thing you want to make sure that you always do is that you have one variable by itself, whether that's the x equaling something by itself so you can substitute it in, or y equals something else so we can substitute that other value in. So good luck on your assignment.